I welcome you all, dear students, to the lecture series in Industrial Robotic course. So last class we have seen, we'll have a small recap of what we have discussed in the last class. So we have just seen what is image processing and how image is acquired using these three different kind of devices like 3D cameras, sensors and cameras. And what is mean by a pre-processing, that is being the initial stage of these things, and how we enhance the image. So in this class, as a continuation of that, we will look into what is called feature extraction. So feature extraction is a key step in machine vision that involves extracting relevant information from the images to aid the further analysis and decision making. Several techniques are commonly used in feature extraction. One is blob analysis. Blob analysis is something different, which identifies and extract regions of interest in an image based on their characteristics of such as size, shape, and intensity. For example, when you weld two plates, what is the amount of material being fused and how these regions are merged, the interlayer deposition of the weld material in between two pieces. So how this joint strength is being calculated is all based on the image that is taken through SEM, that is scanning electron microscope, which identifies the image of the weld zone. So this weld zone is being studied, how this edges are being welded and how the particles are distributed. Everything comes under such a shape, and this intensity. So shape detection algorithms identify and extract specific shapes and patterns in an image, such as circles, rectangles, or lines. So texture analysis techniques analyze the spatial arrangement of pixels in an image to extract information about the texture or surface properties of an object. Okay, coming to object recognition. So object recognition is the ability of a robot to identify and classify objects with an image or video stream. This is typically done using machine learning techniques such as deep learning, which allows the robot to learn the recognized objects from a training data set, right? So it's like a template. Normally we used to tell. So when we tell, remember that there is a wooden duster, it will have a shape of rectangle. So we have to already program that training data set into the system of a robot. And when it touches, it should feel the length and breadth of the rectangle and identify this object is a rectangular object, right? So this is called template matching. It is a simple and effective method for object recognition. It involves comparing a template image with the input image to find the best match. Not only this, this robot has to identify the face. Face recognition is the ability of the robot to identify and verify individuals with an image or a video stream. Again, this is done using deep learning techniques, right? Then scene understanding is the ability of the robot to interpret and understand the context of image or video stream. This can include identifying the scene type, indoor or outdoor, understanding the layout of scene, and recognizing the relationship between objects within the scene. So how these techniques are used in robotics? Object recognition is used in robotics for a wide range of tasks such as grasping, manipulation, and navigation. For example, a robot equipped with object recognition can be programmed to pick up specific object within the cluttered environment, right? For example, we have something called defective pencils and very good quality pencils that are scattered, and we need to identify which pencil is defective and which pencil is not. We can use this kind of object recognition systems that is available in the robotics to find the correct match that is being identified, right? So this is all about object recognition, and we use machine learning and deep learning for aiding this object recognition. So machine learning algorithms can be trained to recognize objects based on the set of label trained images. So deep learning models such as convolutional neural networks have revolutionized object recognition in machine vision system. These models can automatically learn and extract features from images, enabling high accurate object recognition. Coming to the conclusion of the previous lecture series and this lecture series. So image processing is a critical component of machine vision, enabling wide range of application, including object detection, object tracking, and image analysis. So by leveraging image analyzing or processing techniques, machine vision systems are able to extract valuable information from the visual data. So enabling automation and enhancing decision-making process. This is the final outcome of any robot that is being expected. So whenever the robot visualizes any image or any kind of scene, it should have a proper decision-making skills based on the images being interpreted. So I hope you understood what is machine vision and what is image processing in robotics. So thank you all for this kind listening to the lecture. We'll meet in the next lecture series. Thank you all.